Hi guys, so this is Venkatesh. So welcome to Venky's Emerging Edge YouTube channel. So today we are mainly focused about autoencoder. This is one of the main topic in deep learning. First of all, what is autoencoder? Why we are using of autoencoder? Next, what are the different types of autoencoders? So these are main topics are covered in this video. So this is mainly required for the exam point of view or interview point of view. Okay, first of all, what is autoencoder? So it is a one type of neural network. Neural network. It is one type of neural networks. So it learn to compress. It learn to compress the data. Compress nothing but a encoding into smaller representation and then reconstruct data in back. So reconstruct nothing but a decoding. Is it clear? So that's why this is called autoencoder. Autoencode automatically encoding and decoding. Is it clear? So it is one type of neural networks. It learns to compress the data into a smaller representation and then reconstruct the data it back. It's a decoding. This is a autoencoder. Why we are? First of all, it is one type of unsupervised learning technique. Why we are discussing of unsupervised learning is till now we will discuss in last videos we are mainly focused about CNN, RNN. These are mainly focused about supervised data, supervised learning techniques. But here this is completely reverse, unsupervised learning. So that's why we will raise this point. Is it clear? Okay. Next one, why we are using of autoencoders? So generally, autoencoders are mainly for the dimensional dimensionality dimensionality reduction. Dimensionality reduction. In the situation, so some of the students remembering that so dimensional reduction means it's like a PCA. Yes, but PCA is a linear transformation. Linear transformation of data. But here autoencoder is a non-linear transformation. Is it clear? So that's why this is a one is the main thing, dimensionality reduction. The second one is denoising image. Denoising images. So what do you mean the denoise? In case of if any image having some disturbance, that means having some unrelated data. So in that time we can easily removing of noise or unrelated. So noise nothing but a error or unwanted feature. Clear? For example, you are taking some image, that image to be processing, but that image having some error or unwanted features. How can you remove it? In that time, we are using our autoencoders. So what will happen in autoencoders? First, autoencoders compress the data, then go for a smaller, then again reconstructed. That means so before compressing, after reconstructing, both images are same. Then automatically we are removing the noisy. In case of not same, that image contain noise. Is it clear? So this is one purpose. Next one is anomaly detection. For example, we have processing of cats and dogs. We will classify the cats and dogs. But unfortunately, it may be fox, if any bear, if any type of animal will be mixing. In that time, we can easily find out this is a completely different pattern. That is called a anomaly detection. Next one is a future learning. The future learning means we can easily identify that these are mainly applied in ML. In ML we are mainly focused about we can find out the features. But if any feature is complete disturbance, then we can easily find out. So the mainly these are four different features, four different types of advantages for we will using of autoencoders. Is it clear? Okay, that is it. So we know that what is autoencoders, why we are using autoencoders. Next, how it will be applied. Autoencoders works. So we know that the autoencoders contain three layers. One is input layer, next one is hidden layer, next one is output layer. The input layer is related to encoding, output layer related to decoding. Is it clear? Okay. But now the hidden layer is completely related to a bottleneck. Bottleneck or latent space. Check it out now architecture. Then we can easily understand it. So it is your input. It is your input X. Then encoding means our data is compressed. Data is compressed. That is called a encoding. Converted to a smaller. It is like a jet. This is called a bottleneck or latent space. Is it clear? Next again reconstruct means decoding. Then finally get a output Y. This is a input. This is the output. Then finally what is input is given, that is same as the output. But why we are applying autoencoders? Main theme is non-linear transform. Is there any disturbance? Is there any denoising? Is there unrelated data? We can easily remove. This is a main architecture of autoencoders. So how is working? So that means, so what is meaning here? Every time you can say that compressed. So here compressing means, for example, the input, we are taking the input. The input image digit taken as a 7. Okay. Okay. This 7 contain 28 by 28 pixels. So how many of values? 784. Is it clear? Done. So it's given image, then go for encoding 784, then again compressing. The compressing, then what will happen? The 784 is converted to reduce 784 in encoding. It can be reduced into a 32 values. For example, again these 32 values are decoded into a 784. Yes or no? Then here what is input image? 7. Here also display the input image is 7. Then it is a autoencoder process. Is it clear? Now discuss about what are the types of autoencoders. The types of autoencoders are different. Here we are mainly focused about four different types of autoencoders. So first one is under complete autoencoder. Next one is a sparse autoencoder. Next one is a denoising autoencoder. Next one is a variational autoencoder. These are main different types of autoencoders. Okay. Now, so first of all, we are mainly focused about sparse autoencoder. Okay, sparse autoencoder. So sparse autoencoder means here main theme is it can be controlling of change of number of nodes. So generally, what is the autoencoders? We can see the one of the architecture here. See the some nodes. For example, these are input nodes. These are hidden. These are encoding. So here each and okay. So this is a encoder, decoder, input, output, hidden. Is it clear? So sparse autoencoder means if any node is changing, if any node is a penalty, then so there is no problem. Then the input and output is always to be a same. So in that situation, these are sparse autoencoders are using. Generally, here four nodes are there. Input, output also four nodes are there. So then we can say that it is simple autoencoders. In case of if any node is absent, if any node is penalized, if any node is missing, then how can we processing? Then we are using a sparse autoencoder. Then we say sparse autoencoders are say controlled by the changing the number of nodes, changing the number of nodes in a hidden layer, in at each hidden layer, each hidden layers. Is it clear? Next one is next point. That means so penalty. The penalty means if any hidden layer is decreasing, if any hidden layer is increasing, then automatically we are applying of some activation function. Clear? Then so how can you in that penalization technique we can use applying of L1 and L2 regulations. Then we calculate the cost function. L1 and L2 regulation. Why we are in L1 and L2? Then regularization technique. Why go for regularization in case of there is no there is chances for underfit and overfit. Why we are applying? Why we occur underfit and overfit due to some the changing of hidden neurons. Is it clear? So then we have L1 and L2 regularization. Then cost function equal to y minus y hat. Y means expected output, actual output plus lambda sigma of I a power h of I. So here lambda means 0.01 is changing value. That is means a L1, L2 we are taking the lambda value. Okay, L1 less so and ridge. Next one is a means activation function. Activation. So here we are using either maybe tan H, either maybe ReLU, either maybe sigmoid or softmax, what it may be. Next one is H of I means hidden neuron. If any hidden neuron will be changing, then we calculate the cost function. Is it clear? Then we can change that. That means this is a sparse autoencoder diagrammatic representation. Is it clear? So input is represented with the xi, x1, x1, 2, 3, 4 like that. The output yi, y1, y2, y3, y4. This is complete about sparse auto encoders. So finally what I say that these are mainly used for the feature selection. Feature selection. Next one is a in case of few neurons are fired. Few neurons are fired, then we are using our sparse auto encoders. Is it clear? Next go for a few neurons. Few neurons are fired. Then next one is denoising autoencoder. Denoising autoencoder. Here denoising also this is also same as, but here we are removing of noise. That is the same. Autoencoder with same functionality. That means input, output, encoder, decoder, latent data, hidden layer. But denoising autoencoders, what will happen? Here we are mainly calculation of MSE, mean square error. So sparse autoencoder we are calculating the cost function, but denoising autoencoder we are calculation of mean square error. For example, how this process? For example, these are a input, these are output neuron. So denoising autoencoders, this is a input neuron, say output neuron, take the hidden layer. So same we know that. Okay, it is hidden. So first he is given a input. The input is given like a some number 2, but it contains some noise. It's given input to the first input layer. Next go for a hidden layer. What will a hidden layer? Then a smaller size hidden layer. Then again encoding, smaller size, decoding. Finally get a final output. Then output we can removing of noise. Then output we get a 2. So these two values. In this is actually original image is 2, but the original image having some noise, that's why you go given to the autoencoders. But autoencoders given the output is 2. These two output and original image, original input is both are same. Then we can say that denoising autoencoders are perfectly working. So here how the perfectly so how these autoencoders are working perfectly or not, we will calculation of MSE, mean square error. Is it clear? Okay. Next. So these are these are two different things. One is denoising and sparse. These two encoders are very important for an exam point of view. Is clear? Next one is applications. So generally, what are the applications of autoencoders? So already we discussed. First one is a image and image and audio compression. Clear? Next one already initially we discussed about anomaly detection. And next one dimensionality reduction. Next one denoising. The name itself denoising. Next one is a recommender systems like NLP, natural language processing, speech processing, so on. Is it clear? Okay. Sometime asking one more question in this regarding to autoencoders. What are the properties? What are the properties or features? What are the properties or features of autoencoder? This is also very important in interview or exam point of view. Mainly three properties or three features. First one is data specific. Data specific. What is meaning of data specific means? For example, so here I am working with a data set of cat and dogs only. In case of any animal, as maybe a fox, is same as the cat or dog, but this is completely irrelevant. So that's a data specific, one of the main properties of feature. Then only we go for autoencoders. Is it clear? Next one is lossy compression. That means the autoencoders first go for a encoding. Next one is a smaller size, that means a latent, and go for a decoding. That means for encoding and decoding, final in encoding initial input, decoding output, both are to be same. In case of is there any data will be lost, that will be find out by using of lossy compression. Next one is a unsupervised in nature. Unsupervised means it is a unlabeled data. Unsupervised means unlabeled. In case of any data is unlabeled, we are not considered. That's why this is unsupervised in a nature. So these are three main properties of features of autoencoders. So thank you.